This is Algebra 2, Lesson 13.2. We're doing general angles and converting degrees to radians and radians to degrees. To convert from degrees to radians, you multiply by pi radians over 180 degrees. Now, you're looking at that and you're saying, how am I going to remember that? Because notice it's the same thing for that one as it is from radians to degrees. You just have to remember, where is the pi and where is the 180? Is it at the top or is it at the bottom? The way you can determine this, if you're trying to make radians, it has to have pi in the answer. So in order for you to have pi in the answer, pi has to be on top. Pi over 180. If you're trying to make degrees, you're trying to get rid of pi. It already has pi in the answer. So you multiply it by 180 over pi radians. That will eliminate the pi symbol or the number pi, and I'll show you in an example what that means. Example number 3 tells you to convert pi over 8 radians to degrees. Notice we already have pi. So you're multiplying it either by pi over 180 or you're multiplying it by 180 over pi. Which one will eliminate the pi completely? Remember, it has to be opposite. See how pi is on top? It has to be opposite the top or the bottom. It's at the top right now. You want to multiply it with pi on the bottom. So this is not the correct one. You're going to multiply it by 180 over pi. So pi over 8 times 180 over pi. So notice we have the same number at the top and the bottom, that number being pi. It eliminates there and there. So what number goes into both 8 and 180? How can we reduce that fraction? What? Does 4 might, does 2 go into it? Do it that way if you're not sure. 2 times what is 8? 4. 2 times what is 180? 90. So we have 90 over 4. Does the number 2 go into it again? Sure, they're both even. So 2 times 2 is 4, and 2 times what is 90? 45. So we have 45 over 2. 45 divided by 2 is 22 and a half degrees. 22.5. So notice, if you're ever trying to convert radians to degrees, if you don't eliminate pi, you did something wrong. If you're making radians, you have to have pi at the end. If you're making degrees, you have to get rid of pi at the end. So on the side or on the back, let's do this one. Convert 320 degrees to radians. Remember, you're trying to either make it, you're either multiplying it by pi over 180 or 180 over pi. Which one do you want to multiply it by if you want to put pi into it? Take about 30 seconds, see if you can figure that out. Remember, we're either multiplying it by this one or by this one. If you want to insert pi into it, it's going to have to be on top in this case. So since it's on top, we're going to multiply it by the first one, pi over 180. So 320 times pi over 180. So all you need to do is reduce the fraction 320 over 180. What number goes into both of them? Right away, since they both end in 10, you can do that. And then ask yourself what number goes into both 32 and 18. 3 doesn't. 6 doesn't, because 6 times something doesn't give you 32. And 3 didn't, so 6 can't. 2 goes into both of them. 2 goes into this one 16 times, and it goes into this one 9 times. So 16 pi over 9. That is the radian measure. 16 pi over 9, not the decimal equivalent that your calculator gave. What about this one? Convert negative 5 pi over 12 from radians to degrees. Again, you're either multiplying it by pi over 180 or 180 over pi. Which one do you multiply it by? See if you can take about 45 seconds to figure that one out. Okay, we are trying to cancel out pi. Pi is on top of the fraction. You can see it says negative 5 pi at the top over 12. So we want the one to multiply with pi at the bottom of the fraction. So negative 5 pi over 12 times 180 over pi. That's when we multiply it by to change it from radians to degrees. Remember, pi will cancel out pi. Now that's gone. Now we just want to multiply it and simplify. Some of y'all thought it was easier yesterday to just multiply straight across and then simplify it. Other people might think it's easier to simplify it first. The number 12 goes into itself. When it goes into 18, you're left with 60. So the number 12 goes into itself once, into 18 once, and you're left with 60. So into it 15. So a lot of sloppy writing right here, but what we wound up with is negative 5 times 15, and it's over 1 times 1 at the bottom, so you don't need to do that. So negative 5 times 15 is negative. 5 times 5 is 25. 5 times 1 plus 2 is 75, and we made degrees, so it converts to negative 75 degrees. Again, notice the difference between A and B, what we have up here right now. When we converted from degrees to radians, we had pi in our answer, 16 pi over 9. When we converted from radians to degrees, you had radians to begin. We eliminated the pi to get negative 75 degrees. Okay, this right here tells you to convert the degree measures to radians and the radian measures to degrees. 270 degrees. We want to multiply 270. We want to put pi into the answer. So we're going to multiply it by pi over 180. You either multiply it by pi over 180 or 180 over pi. So pi over 180 will put that into our answer. Notice as you're looking at the numbers 270 and 180, right off the jump, you can get rid of this to make it 27 over 18. Then what number goes into both 27 and 18? What is the greatest common factor of both of those? Doesn't 9 times something give you 27? And 9 times something give you 18? That's right. 9 times 27 is 3. And 9 times 18 is 2. So 3 pi over 2. That is the radian degree. Negative 5 pi over 3. Converting that one into degrees. Remember, you want to eliminate the pi. So multiply it by pi at the bottom, 180 over pi. This will cancel out this. Does 3 go into 180? Yes, it does. 3 times itself once. 3 goes into 18 6 times, so it goes into 180 60 times. So we wind up with something that says negative 5 times 60. Notice the pi's are going and the 3 at the bottom is going. Negative times a positive is going to be a negative. 5 times 6 we know is 30. So 5 times 60 is 300. You just add a 0. So negative 300 degrees for that one. Again, that's converting degrees to radians and radians to degrees. Then we have something called arc length and area of a sector. The arc length is how long is this, how long is that arc? We can figure out how long that arc is by taking the radius and multiplying it by the angle measurement. The radius times the angle measurement. So notice it says arc length, S, is equal to radius times theta. Again, theta is that angle measurement. To find the area or to find how big of a piece that is, think about a slice of pizza. To find the area, you take half of the radius squared times the angle. Half times radius squared times the angle. Remember, radius squared, you're going to do that part first. Then you're going to take half of that. Then you're going to multiply it by whatever the angle measurement is. Again, let's look at an example of that. Finding arc length and area. Find the arc length and area of a sector with a radius of 3, or radius of 3 meters, and a central angle of 40. First, convert the angle measure to radians. So, if you have 40 degrees, to convert it to radians, you multiply it by pi over 180. So pi over 180 simplifies to 2 pi over 9. So 2 pi over 9. That's changing 40 degrees, degree measurements, into radians. Then find the arc length. 3, since your radius is 3 and not 1, your radius, it says, is 3 meters. 3 times 2 pi over 9. 2 pi over 9, this is just like 3 over 1 right here. So 3 times 2 gives you 6. 6 pi over 9. And then 6 and 9 both simplify by 3. 3 goes into 6 twice and into 9 3 times. So 2 pi over 3 is the arc length. In order to find the area, let's take this a step at a time. You're going to plug it in. You already have 2 pi over 9. That was our radian measurement there. 1/2 times the radius squared, 3 squared, times 2 pi over 9. So when we do all of that, 3 squared first, this right here is 9. So it's 1. This is simple. This looks tough, but it's really simple. It's 1/2 times 9 times 2 pi over 9. This right here, 9 over 1, this will eliminate this, 9 over 9. This will eliminate this, 2 over 2. So all you're left with is 1 times pi, or simply pi square meters.